So this one's a hydrogen bulb, and this one's a wave.
Oh, okay. And then these bulbs are just.
These are this one's multicolored, and then yeah, one of them's incandescent, one of them is CFL, and the last
Third one.
one of them is also LED, I think. Yeah.
We gotta put the sensor in here. Yeah. We
Yeah.
turn it on.
All right.
Is this like we're supposed to get like 3 peaks?
Yeah, 3 peaks would be good, but you'd be lucky to get them really.
Oh,
Yeah. So did you get 3 peaks?
yeah, we got one of them was really small.
Oh yeah, those are good. Yeah.
Oh, okay. Okay. Oh, and then what does it mean? Draw the electron transitions. Like, is that like the horizontal lines or draw this?
So the electron transitions, like that's like what's happening at the atomic level. Like we are representing each level with a certain orbital, like with like the line, and so that is like what happens. Like that's like what you're trying to show in each individual atom, like how the electron is jumping back closer. Versus in that one, that's just showing the intensity versus wavelength of the electrons, right?
Right.
Of what types of electrons are emitted. So, what is the question exactly asking?
So it's asking the electron transitions and the hydrogen and that creates the photon emission.
Right. So you've got particular wavelengths of electron intensities, right?
Yeah.
So draw the corresponding things that happen in the individual atom. So draw the lines. The
Okay, so
horizontal
draw the
lines.
horizontal lines. But then what? It's like, is that like n equals 1, n equals 2, n equals 3?
So that will depend based on. So you should calculate what energy levels will be for each transition, and then based on that you can tell what n it is. So you have the wavelength over there. So plug the wavelength in the formula, and then yeah, you should
And
get.
then that energy. Okay, got it. Okay, cool. Thank you.
And then you compose. Okay, so now you're gonna sub in what E you found in there.
Yeah.
So I think
Can I just take that off?
this energy is actually negative because it's an attraction force that you're measuring. So yeah, you just put the negative in there and it should be fine.
Okay, that makes sense. Okay, and then which one of these is the mercury? Or-
This one's a mercury.
oh, how do
yeah.
I describe this?
There's a switch behind it.
Oh, okay.
Yeah.
Okay, cool. Thank you.
No problem.
Just make sure.
Yeah. Because we found this, we found 43, no, 42 and then 32. We tried different combinations, but we couldn't find this guy.
Oh, was that wavelength outside the? Where did you get that wavelength from?
Well,
I don't think so.
but let's redo it.
You don't have to redo it. Just show me the. You took a snapshot.
Oh, but I think she got rid of the
Oh, it's right
data.
there.
Oh, it's there. Okay.
Yeah.
Oh, so we're supposed to pick things that line up, right?
Right. Did you do that?
No.
Oh, okay. So yeah. I'm surprised you even got those numbers if you didn't pick peaks that line up.
Oh no, we picked the reference.
Yeah.
Oh, yeah. You pick hydrogen, yeah, and then pick peaks that line up.
Yeah, so it would be this 490.
Yeah.
Oh, check your intensity.
What should we do with that?
Like make it smaller. This is like really like. Yeah.
Yeah, zoom out. You can drag this axis to zoom out that.
Yeah. This is what it really should look like. Like it should look straight and it should only be peaking at the levels. Yeah.
So we probably like 650.
Do you want to increase the smoothness? Oh, this is a snapshot, so you can't snapshot, so you can't do that. But yeah, so you see a peak right here, so that is one, and there should be a peak here, but it kind of got shifted a bit, but that's fine. And yeah, I think there's another peak here. So next time when you take the data, just make sure it smooths out so you can only see the peaks where it should be.
Do you know how to label? Do you know how to get the wavelength?
Yeah. So do you know how to do that? Sorry.
No.
So you just click on this little box here, and you can drag that. No, drag this to the peak,
So this one.
like at the point where it should be. Like yeah, and that's where you can see it.
You want to do it to the actual one.
Yeah, I'm saying to that. Yeah. Oh, okay. Sorry, I didn't see. I couldn't see from here, but yeah, that looks like a peak. It looked like a peak to me. Sorry.
Okay, so then we just do that for.
Yeah, and that's how you find the wavelength. So how did you find the wavelength for these then?
Oh, we just use the reference.
Okay. But yeah, this is the values you're supposed to use.
Okay. So we just need 3, right? Like we don't need a lot.
Yeah, you just need. How many is it asking?
It doesn't ask. Yeah, let's say.
You could do 3 if you want. Yeah.
Oh. Thank you.
But I think 2 is fine too.
Oh, okay.
Yeah.
We'll do that for the next one then.
Okay.
This is 490, which is really close. And then. Oh, thank you.
From you get them.
Just calculate them, but it says it wants to know what these could account for in the bulb.
Yeah, we figured out that it has mercury in CFL, but like we're not sure like what the other materials.
What this
Is it phosphorus?
Isn't the why do you think there are 3 materials?
Well, because these are all the wavelengths we calculated.
Right.
And these 3 correspond with the ones in mercury, so we know mercury's in there. But these 2 don't correspond with either mercury or hydrogen. So it's asking what it could correspond with.
So did you know what's in the CFL lamp bulb, right?
Yeah,
you looked it
it
up?
does have mercury. Is it phosphorus?
I mean the name is a big giveaway. Yeah. So like you can probably like look up more like something of that sort. So that's one of the other things that's in it, and what? Yeah, but one of the bigger ones is probably some fluorescent gas. So just like look it
Would
up.
it be fine to just mention it's probably a fluorescent gas?
Yeah,
or-
I think that should be fine. Right?
What kind of things are fluorescent?
Do you have to like find the exact fluorescent gas, or is fluorescent gas enough?
I mean, I think phosphor might be fine.
Okay, all right. What you?
Like,
So what happens is there is a certain gas in the bulb, and then what the bulb like does is there's electrons that pass through the bulb, and it has to go through the gas to complete the circuit. So that way it completes the circuit. But when the electrons go through the gas, they hit the electrons in the gas, and they cause those electrons to get excited and go to the next level. And when they come back to their actual levels, they release photons, and the photons are what you see as light. So the gas has to go throughout the bulb for the electrons to hit them. Thank you. Why?
At outputting the visible range. I know that the CFL bulb is actually like more efficient, like energy-wise, but what does it mean by the visible range of the photon?
So,
Like,
yeah, go ahead.
no, just like because like this one is like it emits the range, while the other one is like very has like 3 peaks.
Right. So which one has more? Which one has the more peak sources? Which one is the broader one?
So this is the broader one. The
Right. Which
incandescent-
one is it?
The incandescent.
The incandescent bulb.
Yeah.
Okay. So what do you think the broadness signifies versus having like exact peaks?
That it emits all the light, like all the different colors of the invisible spectrum.
Right. Okay. So do you think it's more efficient to emit
Like all of them.
all of them versus just emitting particular?
Particular one.
Right. So
Like, yeah.
that way it's just emitting the exact ones it needs to make that particular color
Oh, okay. That
versus
makes sense.
just emitting a bunch of them. Also, it depends on what the unit of this intensity is. Do you know what the unit is? Like its energy per watt.
It's gonna be
What?
the peak was at 670.
Like around 670. What do you? What was your question?
So do you know what intensity signifies?
The brightness.
Brightness, right? But so you say you wanted to convert that to units of like in terms of energy. Do you know how that works? Like so pressure is force per area, right?
Yeah.
So do you think intensity is analogous to that in some way?
Yeah, it's like yeah,
It's like what?
power over area.
Intensity?
Isn't that what it is though?
Wait, yeah, it is. Like it is pretty analogous to that, but really it's like energy worth per some like measurement, like distance or time or
Yeah.
area. So that's really what it's doing. So do you think if you increased like the broadness of this, like it's having a lot of different intensities, right? So it's not as energy efficient as versus just having fewer intensities.
Okay. Thank you.
Thank you.